right? So the next category, like the first category of language in database is going to be DDL, data definition language. So you all know that data definition language, it is used to define the structure of the database or the schema of the database. So create database, database name command, create database command, create table command, alter table command, drop table command, and drop database command. They command are data definition language, right? So you can specify the schema or the structure of the database by a special language called data definition language, right? So the schema structure of your database is defined by a special language called data definition language. So you can also specify the storage structure and access method used by the database system by a set of statements in a special type of DDL called data storage and definition language, right? So you can specify where the data has to be stored in a database, right? And you can also specify the access structure of the database using a data storage and definition language, right? So the output of the DDL is placed in the data dictionary, which contains metadata, that is data about data, right? So once you execute a data definition language statement, the output is going to be a data dictionary or metadata, which is data about data, right? So this is about data definition language. To define the schema of your database, we go for data definition language. So we also have a special language called data storage and definition language, which defines the storage structure and the access methods used by the database system and output of DDL statements. It is going to be it is placed in data dictionary, which contains metadata, that is data about data, right? So whenever we study something about DDL statements, we also study about the integrity constraints. So the different types of constraints in DDL, it is going to be domain integrity constraints and referential integrity constraints. So domain integrity constraints, it specifies a set of possible values that is associated with every attribute, right? So for example, you define a student database, you create a table, you specify the student ID is going to be integer, name is going to be character, age is going to be date, and so on, right? So while you define a schema or the structure of your database, if you are going to specify the possible values that are associated with every attribute, whether it's going to be integer, character, numeric, date, time, and so on, it is going to be called as domain integrity constraints. And referential integrity constraints, it ensures that a value that appears in one relation for a given set of attributes also appear in a certain set of attributes in another relation. So referential integration is about defining a foreign key in a relation, right? So whenever you refer the primary key of one relation in another relation, it's known as foreign key. So you need to ensure that the value that appear in one relation for a given set of attribute also appears in a certain set of attributes in another relation, so that you will be able to join multiple tables. We go for this referential integrity constraints. And assertion, right? So you would have studied that assertion. Check is an assertion. It is a condition that a database must always satisfy, right? So for example, while you are defining a table, you are going to have some assertion that states that every department must have at least 5 courses offered every semester. So it's an example of an assertion, right? So for example, a student has to register for at least 6 theory courses and 2 lab courses every semester, right? So that's an assertion. He has to register for some minimal number of courses every semester. It's an assertion. So we have check constraint in SQL. So it's a condition that it has to be satisfied in a relation while you are inserting the data.